Sex inheritance, there's three different types of sex inheritance. There's sex-limited inheritance, there's sex-influenced inheritance, and then there's sex-linked inheritance. So the easiest one of these to get, or the easiest one of these to, I guess, identify, is the sex-linked inheritance pattern. This is where it's an inheritance pattern that is on the X, or mostly X, because remember there's like very few genes, Y chromosomes. I guess for an example of this, and this follows a sex-linked, it can be dominant or recessive. There's lots of examples of X-linked diseases in humans, but I guess an example that I'm going to say would be Duchenne muscular dystrophy. That would be an example of one of those. Let me switch my colors real quick. Okay, so next on the list would be sex-influenced inheritance. In both sex-limited and sex-influenced inheritance, they do share one thing in common. These are both traits that are located on autosomes. What is an autosome? Well, it's any type of a chromosome that is not a sex chromosome. So don't let that definition kind of trick you. But a sex influence, think about the word there, influenced. So what this is this is where there is variation in how males and females that's a hard to read, express a gene. So I guess if I were to give an example of a sex-influenced trait, a trait that is, its expressivity is determined by the sex, an example of that would be, I'm just going to draw it down here for an example, body hair. Body and facial hair. I know this is kind of gross to talk about, especially in certain aspects, but both men and women, both males and females, and I'll switch colors if I can to, let's go with blue. So both males and females both have expressed the trait for body or facial hair. But obviously hormones, it's an H, hormones can dictate how much of this trait is being expressed. Obviously, males express this trait a lot more than females do. And then this also entails a lot of secondary sexual characteristics. For example, men and women both have, trying to think of it, they both have breasts, but they don't have, there's variation in how much they develop over the course that's dictated by hormones. Now, a sex-limited or I guess a sex-limited inheritance pattern. It's on an autosome, yes. But what this is a, so I guess if we were to look at this as a volume knob, that it depends on how high it is, this is a on or an off scenario. For example, okay, it's located on an autosome, so both males and females have these traits. Males and females have these traits, but it is only expressed. It's only, I'm just going to say on, but in this context it's the same thing as saying expressed. On in one sex. So I guess an example of this would be lactating. So lactating breasts, right? Okay, so I'm a guy. This is kind of crazy when you think about it. I have the genes, the DNA necessary to have this type of a phenomenon happen, but because I'm a guy, my hormones are so predominantly dictating, this gene will never, ever, 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 ever be turned on. However, for females, they have this gene, and so this gene will be turned on. It's for sex-limited, it's an on and off phenomenon. For sex-influence, try to think of it like a volume knob on your car.